Okay, today we're going to learn how to do a 5 by 5 can. So this particular video is already assuming that you all know the different parts and sections of a can. So I'm going to talk about how to easily solve a can. So the first step I usually do is find my single cell. We call these freebie cells. So fill in your single cell, and we have any more single cells. So single cells are cells that don't have an operation. See, this has a number and a math operation. This just has a number. So fill in all the single cells that you see that don't have an operation. Those are single cells. We call them freebie cells. And then I like to write the numbers 1, 2, 3, 4, 5 because we have 1, 2, 3, 4, 5 rows or columns here. We can use these numbers to complete all of our operations. And now we shall begin. So with can, you know that you can only have 1, 2, 3, 4, 5 in one row and one column, and no numbers can overlap. So we have to find possible combinations. This means two numbers. Okay, we have two cells here added together equals 6. So I have to find all the combinations or all the factors of the two numbers added together equals 6. So here I believe 4 plus 2 equals 6. So I don't know where I want to put the 4 or where I want to put the 2. So I'll put the 4 and 2 here. 5 plus 1 equals 6. Once again, I don't know where I want to put the 5 and which box to put the 1 in, so I'll put them there just to remind me. Now, let's talk about this because 3 plus 3 equals 6, but remember, we can't have two 3's in the same row or the same column, so I can't use that combination. And then 3 plus 2 is 5, 3 plus 5 is 8, so there's no other combinations for two cells added together equals 6. So 4 and 2 and 5 and 1 are our only factors. Okay, so I'm going to look to see if I have any other matching cages that have the same cell setup as this one. So do I have any more 6 plus? I do. And we already found out that the combinations were 4 and 2 and 5 and 1. And we already found out the combinations were 4 and 2 and 5 and 1. So I've got the work done for 3 whole cages so far. Now let's go to the next cage. This cage means that there's 2 cells, okay, added together equals 3. We know 2 and 1 is a possible combination. Matter of fact, there's no other possible combination. This has to be 2 and 1 because there are no other numbers here that I can add together to equal 3. I don't have, I have 1 over here. Another 3 plus 2 cell. So 2 and 1 would be the only combination there. So now we're moving. Okay, so let's look at 7 because I have two cells added together equals 7. The same thing here and the same thing here. So let's look at possible combinations. 5 plus 2 equals 7. So I can do a 5 and 2 combination. 4 plus 3 equals 7. So I can do a 4 and 3 combination here. Let's see, do we have any other combinations? 4 and 2, no. 3 and 3, no. 3 and 4, we did. 5 and 1 is 6, no. So those are the only 2 possible combinations. So here I can fill that in for the next cage that has the same operation here. 5 and 2 and 4 and 3. I have another cage that has the same operation. 5 and 2 and 4 and 3. Now we have a 5 plus here, 2 numbers, 2 cells. Okay, 2 cells added together equal 5. So what 2 numbers added together equal 5? We will, 2 and 3. 2 and 3. And then we also know that 4 and 1 added together equals 5. And there are no other possible combinations there. So I want to try to get started here. Because we know here we have a 5. And I can't have 5 in the same row here. So I know I can't use my 5 and 2. So I'm going to erase that combination. I have to use 4 and 3. If I know I have to use 4 and 3 here. So let me see what numbers are missing. I got 3, 4, and 5. The only thing I'm missing are 1 and 2. Okay, so that means a 2 would have to go here or a 1, and a 2 would have to go here or a 1. What are we going to do? Which one combo are we going to use? Well, let's keep moving and see if we can come back to that and get a clue. Okay, now let's look here. We have 1 and 2. I have to use 1 and 2 here. So which means I can't use the 2 and 5 combination here, so I'll erase that. And I have to use 1, 2. That means I have to use the 3 and 4. What number is missing? 5. So 5 would have to go here. Now that I know 5 has to go here, I know which combo that I have to use. So I'll use my 5-1 combo. I'll use the 5 here. So that means that the 1 goes here. Very good. So now in this row, I would have 1, 3, 4, 5, which means this one has to be a 2. So if this has to be a 2, I'll use a 2 here. Which one of these combos has a 2? This one. So I know I use this combo. I've already used the 2 here, and now that means I have to put the 4 over here. Okay, this also tells me that I can't use this 4-3 combo because I already have a 4 in this row. So I can get rid of that 4-3 combo. I have to use the 5-2 combo. So 5, 2, and 4, what numbers am I missing in my sequence? 5, 2, and 4. That means the only two numbers missing are 1 and 3. So that means here I would have to use a 1 or a 3. This, we can wait because either one we can do here. So we'll wait and come back to that one. See if we get some more clues along the way. Here, I have a 4 already in this row. So I know that I can't put this 4 here. I have to put the 4 up here, which means my 3 will go down here. So now I have 2, 3, 4, 2, 3, 4. I'm only missing the 1 and the 5. Here, this tells us that 1 and 5 is our combo that we use over here, which means I can erase the 4 and the 2. Good for us, but we still don't know which way. Do we put the 1 here, the 5 here, the 5 here, and the 1 here? But we're getting closer. Now let's look back over here. 4, 3, 5. We know 1 and 2 are missing. If we knew which row or which combo we were using here, we'd be able to do our 1 and 2. But let's go and figure out a different cage. So we have 3 numbers added together equal 9. Let's look at the different combinations. So 5 plus 4 equals 9, but that's not 3 numbers. So we have to go somewhere else. 5 plus 2 is 7, plus another 2 would be 9. But I can't have doubles, 2s in the same row. Let me see. 4 plus 3 equals 7, plus 2 equals 9. So maybe I can use 4, 3, 2. 4 plus 3 equals 7, plus 2 equals 9. Let me see what else. 5 plus 1 equals 6, plus 3 equals 9. So 5, 1, 3 could be a possible combination. And do we see anything else? 4, 5, 6, plus 3 equals 9. We've already used that. So those two combinations are possible here. Let's look at this particular cage. Now, because we have this cage shaped like this, it doesn't matter if I use doubles because I can put one number here and the 2 doubles can go here and they'll never cross each other. So let's look at the possible combinations for 3 numbers added together equal 11. So I see 5 plus 4 equals 9, plus 2, 10, 11 equals 11. So 5, 4, 2. Okay. Or let's see if we can find some more. Let me see. 4 plus 3 equals 7, plus another 4 equals 11. 4, 4, 3. 4, 4, 3. It's a lot of combinations, I believe. Oh boy. Let's see. 4 plus 2 equals 6. 6 plus 3 equals 9. No, 6 plus 5 equals 11. So 2, 4, 5. Oh, which I have that already. Okay, well, let's move on. And if we need any other possible combinations, we'll have to figure that out a little bit later. Here, I see another clue. If I have to have a 4 here and I have to use 4 and 3 here, that means my 4 cannot go here. So it'll be double with this particular row. I have to put the 4 here and the 3 here. So let me check my row. 1, 2, 3, 4, 5, which is great. Very good. We have a row completed there. Here we have 4 and 3, which is missing 1, 2, and a 5. So that means 5 has to go here. And then the 2 from this sequence must go here. Very good. Since I have a 2 in this row, I can't put this 2 here. So that means this 2 must go here. And this 1 has to go there. Very good. We're moving on. 1, 4, 2. Where do we go next? Let me see. If I use, here is 2, 5, 4, 2, 5, 4. That means 1 and 3 are missing. So here I would have to use 1 or 3. I still can use this 3. Or I could use this 1. So we're going to have to figure out some more clues, buddies, to figure out where do we go from here. Okay, well, let's keep moving. Okay, we're going to keep pushing on here. So I'm looking to see the combinations here. I can use the 513 here or the 432 here. Here, I was looking at this one. I can't use a 5 in this particular row because I have a 5 here. So I probably won't be able to use this 513. I can use the 432, but I know the 2 can't go there. So let's move on to another one before we figure that out. I found another combination for 11. So 5 plus 3 equals 8 plus 3 equals 11. And we tried the other two and those didn't quite work. So let's try this one. When I have the double numbers in the L-shaped cage, I can put the one number that's single by itself there, and then we can put our doubles in the corner here. Okay, so that helps out a little bit. And let me make sure 1, 2, 3, 4, 5. Make sure we're still in compliance with the rules of the game. Okay, so now we have another cell done. I know I can't use the 2-3 combo here because I have a 3 here and a 2 there. So I have to use the 4-1 combo. I can get rid of my 2-3 combo here. If I use this 4-1 combo, I can't put the 4 here because there's a 4 there. I know the 1 must go here and the 4 has to go there. So now I can count to see what number is missing in the sequence here. I have 1, 2, I'm missing 3, 4, and 5, which means the 3 has to go here. If the 3 has to go there, that means these two numbers have to be a 4 and a 2 because we just used the 3 there, 4 and 2, which means here's a 4. I can't put the 4 here. I have to put the 4 over here, and that means that I'll have to put the 2 here. Okay, so now let's look at our cages. We have 1 is missing. We got 2, 3, 4, and a 5 is missing. So a 1 and a 5. Here, I have to put the 1 here because there's already a 2, and put the 2 over here. Here, I have to put the 5 here because there's a 5 over here, and put the 1 here. And so let me go back and check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. When you become an expert, you don't have to check 1, 2, 3, 4, 5. Yay, we did it. All right, guys, that's how to easily solve a Kin Kin puzzle. Love you. Mean it.